Sam and Alex, I'm going to hand over to you for a hopefully interesting, I think it's going to be fascinating conversation about LLMs.
Hopefully interesting?
Sorry.
It's definitely going to be.
Yeah,
Okay,
no,
one
it's
second.
definitely going to be interesting. You might it was coming from my fear that you might lose me, but I'm here and I'm ready to hear more about how
we're taking everyone with us.
Okay. All right. And just for everyone's benefit, there's been for like the last year, there's been a conversation on WildLabs about ChatGPT in conservation, which has been like a really interesting spark of some different talks in Variety Hour and some ongoing conversations. And that's where, Sam, did you jump in or did Alec jump? One of you jumped in. Maybe it was Alec.
Yeah.
Jumped in and shared that you guys at Conservation Evidence were exploring large language models for and their use in the work that you guys do about promoting evidence-based conservation. So we wanted to hear more about how you're using it, because I think it's something that everyone particularly in like the last 2-3 months, I've just been hearing from so many groups. Should we be using generative AI? How do we incorporate it in our workflows above and beyond just dealing with sensor data? And I think this is a really interesting application. So we want to hear more. So take it away.
Well, the short answer to that is carefully. Okay. So we're going to be talking about the Conservation Evidence Project here at Cambridge, and our project, which is AI-assisted evidence synthesis. So we're going to talk about two things today. We're going to talk about, firstly, what is conservation evidence anyway, and then how we're planning to implement these large language models into our evidence pipeline. And I'm assuming everyone can see my screen. So firstly, what is conservation evidence? So there is an evidence crisis in conservation. And what I mean by this is that evidence is rarely used to make decisions. We think about 75% of the decisions that are made around conservation projects don't consult any of the available evidence. They usually just rely on anecdotal evidence or what they feel like is probably best in that situation. Other fields have a really strong evidence-based approach. For example, in aviation, if a plane crashes, there's a thorough investigation, and this feeds back into how global aviation operates, and unsafe planes are removed from service and safety standards change. And in medicine, treatment recommendations are based on evidence from randomized controlled trials and cases that are written up from practice. And that feeds back into how doctors operate. But this isn't what happens in conservation. Conservation practice is often really siloed, and there's very little feedback into the general community on what works, and even less so on what doesn't work. So the aim of our work really is to build this evidence base and create a culture of evidence use in conservation. And we do this by building tools, working with conservationists, policymakers, and synthesizing evidence on conservation effectiveness. So systematic evidence synthesis. So I'm going to talk through quickly what a normal systematic review would look like. So you start off with a very specific question. For example, how effective are herbicides for managing Japanese knotweed? You would then use keyword searches to go to your favorite online repositories like Google Scholar or Scopus or Web of Science. You would then be gathering all your grey literature, so your reports from NGOs and governments. You'd be contacting researchers for unpublished reports, and you'd be searching that literature in multiple languages, ideally. And then once you have all your papers in one place, you have to go through them all and decide which ones meet your inclusion criteria, which ones actually talk about how effective herbicides are for managing Japanese knotweed. And once you've done all that, you write it up in a big paper, and you publish it in a huge journal, and no one ever reads it, especially conservation practitioners. And it also is a static piece of work that can't be inquired or updated in any kind of way. So this is where conservation evidence steps in. And we have a very different approach to evidence synthesis, which is subject-wide evidence synthesis. And our goal is to synthesize the global evidence for the effects of all conservation actions on all of biodiversity. So it's pretty easy. And this is our kind of like pipeline for how we work. So our question is, how effective are conservation actions? And instead of using keyword searches, we just go straight to the journals, all the conservation journals and the wider literature, and we go to issue 1, paper 1. So we go to, for example, Restoration Ecology, published between 1993 and 2024. We go to the 1993 issue and get the first one, and then we just go through every single paper in order. And then we say whether it's relevant, whether it tests a conservation action, or whether it doesn't test a conservation action. And the idea is, once you've done that, you never have to go back to that journal ever again. Whereas if you're querying with keywords, you'll be brought back to the same journals again and again in different contexts. This idea is you never have to go back to that journal ever again. And we have 30 different folders where we say, so that this first paper has an outcome that says how good are conservation actions for birds and for forests, another one for mammals or butterflies, So that's how we break it all down. We have about 30 different categories we sort these papers into. And then when we want to synthesize that evidence, which we do in things called synopses, we gather 15 to 20 experts, and we say to them, what are all the different ways that you would try and conserve, in this instance, terrestrial mammals? And that includes everything like putting up fences, stopping hunting, doing protected areas. So they give us a big long list of all the things they think they might be able to do. And we go to our folder where we've gathered all of the evidence from these journals, and we try and find the pieces of evidence that support those actions. Well, not support them, but deal with the effectiveness of those actions. And often, loads of the stuff they suggest doesn't actually have any evidence to suggest whether it works or not. It's just stuff that's done because it's done. And then we publish them in these synopses. And so far, we've been through 1.5 million papers. We've distilled them down to over 8,600 studies, which have actually directly tested conservation actions across 17 languages. And we have evidence for over 3,500 different conservation actions. And they're published in these synopses, like I mentioned earlier. So we have one on amphibians, bats, terrestrial mammals, farmlands. So we do taxa, but we also do habitats as well. And then there's the website, the Conservation Evidence website, where we have all of the actions uploaded with all of the evidence. And it's all been summarized by hand, by people who have taken that full text and then they've written a small paragraph which sums up the key results so that people can go here and find the stuff that works. But this is a really slow process. The process has been going on for about 20 years now, or near on. But we can only really add like a few hundred papers a year because it's pretty hard going. And we reckon we've had about 75 years of research time so far dedicated to this project. And so now we're looking at how large language models can help us do this faster and better. And that's what Alex is going to talk about now.
Brilliant. Thanks, Sam. So yeah, I'm going to talk about how we're applying particularly large language models to speed up the conservation evidence project. And kind of our plan is split into 3 parts. So the first is looking at how, in terms of when you first do your screening to find your relevant studies, how do we use large language models to automatically find and categorize those relevant papers? And then the next stage is looking at how you extract the information that you need to summarize those studies. So creating those summaries that are on the Conservation Evidence website for practitioners. And then finally, developing an interface for like a chatbot, basically, for the website that practitioners can go on, and rather than trying to search through the database, they can actually just interact with a chatbot to get the information, the evidence that they want to find out about. So I'm going to start with the first one. So you might remember Sam was saying about how we manually go through, in a very painstaking, methodical way, journal by journal, issue by issue, paper by paper. And this really lends itself quite well to AI, because basically we've been generating a massive training data set over these last 2 decades that we haven't really been thinking about, which is quite something. And so what we've been doing is the first part of this stage of automatically finding relevant papers and categorizing them is to use something called an embedding model. So usually we think about like large language models generating text, but what this one does is instead it ingests text, and what it outputs is this kind of numerical vector. So it's basically, you can think of it as kind of almost like the DNA of a study or a paper. So all of the semantics within that text, it's basically trying to summarize that in a higher dimensional space using lots of numbers. So basically we're turning papers into lots of numbers. And And what that means is once we do that, so we can go to these big databases, it turns out, of all the papers out there. So there's like things like OpenAlex is a big database, and it contains 250 million papers and information on them. And so what we've done is once you've got all those vectors for each paper, so the essence of those papers, and you have all that data, what you can actually do is then look at where do the papers cluster together based on all those parameters. So you've got hundreds of these different parameters, and what we're showing here is a representation of that in a 2D space, so condensing down all those parameters, hundreds of parameters, down into two. And what you can see here is in green, we've got papers that are included in conservation evidence, and ones that are grey are the ones that we haven't included yet. And you can see that we're going through different depths as well of categorization. So this is just looking at the titles of papers from that big database I mentioned. And so as we go through, you can kind of see how already this embedding model has been able to kind of categorize different areas of conservation that these studies have been looking at, and kind of cluster them based on what we found. And so the results of this are quite encouraging. We seem to be covering a lot of the studies that are in biodiversity conservation in these different fields, but also it's highlighting potentially areas where we could add more studies on different topics. So that was our kind of first attempt at it, and that was just looking at the titles of papers, and it kind of blew us away as to how good that was. So now what we're doing is going further and saying, okay, well, a human would actually go and look at the abstract as well, and not just the title. So now what we're doing is training a sort of small large language model, or small language model rather, which is made up of 0.1 billion parameters, which still sounds big, but is quite small fry really nowadays. And what this does is it acts as a classifier. So it basically will tell us, recommend to the researcher whether this study is likely to be relevant or not. And so what we're doing is we're building this into a web interface that a researcher could then use. So it brings up studies that it thinks are relevant, and then it gives a recommendation as to whether the researcher should include it or not. And what we then do is we use a bigger large language model, so like Llama 3, which is one of the newer ones, 70 billion parameters, so much more complicated. And what this is doing is telling us what the target taxa or habitat of that study was. So what did it test the conservation action on? What is it actually trying to protect or conserve? And we fine-tune this with the conservation evidence team's guidance documents on how to go about assessing papers. So it's learning from how a human would do this. And so this is literally, we just got this today. This is kind of a screening interface we've been developing for the researchers. So it brings up a possible candidate study, the title and abstract, and you can see it's given a possible categorization that it thinks. So it thinks this is looking at mammals. You can see it does seem to be testing conservation action, the translocation of these possums. So that gets a tick. But also it gives us, if we look a bit further, we can click on the confused face, and it will give us some information about what it thinks the study is looking at, and whether we should include it or not. So in this case, we've got different inclusion criteria as to which studies why we should include a study, and in this case, it's recommending that it is indeed testing the impact of some kind of conservation action. And so the researcher would then go through these and accept or reject them. So it's a much quicker way of bringing these studies to the researcher and keeping a human in the loop, but also speeding up the process of tagging what might be in the study. So then once you know what relevant studies you've got, we then move on to kind of extracting the data that we want from them. And so luckily we have a really structured format of how we write study summaries already. And this really lends itself to these large language models because we can prompt it with these kind of structured summaries to get it to basically fill in this information. So where was the study done? What did it look at? What study design did it use? What did it find? Where did it occur? When did it occur? So what we do here is a slightly more complex process, but we basically take the relevant paper and the full text this time, and we put it into an extractor model, which basically says, okay, you're looking for this information. I think it's in this place in the document. And we then feed that to a summarizer model, which then says, okay, so you think it's in here. I'm going to try and look in this bit of the text and tell you what I think is the location of the study or when it was conducted, say. And then what we're planning to build is an interface that will basically overlay this on the full text, so the PDF or document, and it will allow the researcher basically to get a really quick idea of like, okay, I need to write a summary in this structure, and this model is telling me this is where it thinks the information is. It thinks it's been conducted between 2022, 2023. Its sample size is 3 sites, and the researcher can then quickly click yes or no, or edit, to also provide feedback to the model as well, and then write the summary. So we're hoping this is a much quicker way of speeding up those summaries, that writing. And then finally, we're trying to make a chatbot for the website. And so at the moment, the website's pretty static. We're trying to update it, but a much better way to allow users to query it would be to have some kind of co-pilot for the website. So a conservation co-pilot that would allow the user to ask questions and query it, basically, a bit like an intelligent search, but our ultimate vision is that it would also be able to provide recommendations based on the evidence by considering where the user's from. So maybe you're working in a particular part of the world on a particular species. It would tailor its response based on where the studies have been conducted and how relevant they are to your local context. So it's going to be providing more customized evidence-based advice as well. So that's the ultimate vision. We're not there yet, but we've got an intern working on it over the summer, and they're already making a lot of progress, so it's quite exciting. But all of this, I guess, comes with some caveats. Oh, I forgot to mention, it's a bit like a Clippy. If people remember, some people remember Clippy, it's going to be a bit like a Clippy for the conservation evidence website, but hopefully better. So the key takeaways from all this, I think, are evidence synthesis can be sped up with AI, and particularly for the way we do evidence synthesis, we think it can be a really big benefit because with the industrial scale we're doing this on. But obviously you can't just throw AI and LLMs at these problems. You've got to really think carefully about how you design it, because there's obviously shortcomings with these models. They can't just be used for everything. And so we're still trying to figure some of those out, but we think it has a lot of potential. And so any system we're going to develop in the future is always going to have a human in the loop at several stages. So this is never going to replace a human doing evidence synthesis, but it's hopefully going to make the process more efficient and hopefully even better than it is with just a human involved. So that's all, I think. So thanks very much for inviting us to give this talk, and we're happy to take any questions on what we're doing.
Thanks so much, guys. That was really interesting. I enjoyed that didn't enjoy it. It was interesting that the example you used with possums in New Zealand, where possums are an invasive species, the recommendation from your AI was that it was a possible use case for evidence for successfully translocating and restoring populations, which is not particularly what that paper was saying, right?
No, exactly. So it's well, the thing is, I literally just picked that at random. I didn't really look at it. So we in the moment.
Sorry, I didn't mean to throw you under the bus. It was more a case of it's really great evidence for what AI, like a large language model, can do, but also the real humans in the loop. It's mainly that how good it is at picking out tests of actions on species from all the papers that exist. Yeah. So it's not picking out stuff about carbon nanotubes.
Yeah. Because this is
I was just going to say, I guess the follow-on question is one that Frank raised, which is have you tested your system against the previously human work you've done before? Human-assisted work or human-led work you've done before? Or is that going to be upcoming?
Yeah, so that is part of the process that we're doing. So this is very much, this interface at the moment is just for us to basically test how good it is. So we have feedback and to feedback, yeah. So So yeah, we're planning to do a lot of human evaluation on it, but we also have, you know, a lot of the existing examples. So all of these papers that will come through that interface are ones that we haven't looked at yet. But of course, we can also test it on, you know, is it retrieving the ones that we know are relevant as well. And yeah, I guess the key thing to say about that tool is that, yeah, the main things that it's going to be doing is telling us, you know, getting it in a state where it's easy for a human to accept or reject it. And the recommendation bit is very much, so the summarization bit is kind of not really what we're looking at there. It's more about whether to include or exclude and what it's looking at. And then later on is much more about, you know, that's just the screening stage as to whether it gets allowed to the next stage. And the later stage is much more about summarization, what's it actually looking at. Yeah.
How many steps do you think there are? So you put out the idea of a conservation co-pilot built on your data. Have you explored, like, it seems to, because I've been wondering if we should build, like, obviously the same sort of idea, but based on the data that we have on WILDLABS for conservation tech. And then my immediate next step is like, oh, it would be really cool if we could combine the good data on WILDLABS, which like with other partners like the Red List, or you got, like, to build an overarching conservation co-pilot that has, like, all of the information in it that's trustworthy. I don't know. Have you guys thought about collaborating with other groups on that front, or would you just build one based on the data that you have?
So the first stage is just, you know, we're just trying to do a chatbot for the website, and the ultimate vision of that co-pilot is, yeah, that it would have geospatial data sets. It would look both at, you know, threats and solutions. So it would be like kind of the you know, conservation handbook, really, but you're able to interact with it. But yeah, it would be across organizations, and there's a lot of work that we work in the Cambridge Conservation Initiative. Yeah. And so there's loads of organizations in the building, and one big project at the moment, or there's talk about it anyways, how do we integrate all the data sets across, like, BirdLife and IUCN and you know, all the organizations in the building? How do we bring all those data sets together in one place? So I think if we can achieve that, then the natural next step is to have some kind of interface to query it, like you're saying. So, but
it might be worth chatting to some other groups and seeing where the collaboration lies. I'm conscious of time, and I think there's we can have a longer conversation in after hours. But just to say, if anyone else is thinking in this area, reach out to Sam and Alec. But also there's the Bezos Earth Fund call for AI projects at the moment that might be worth having a look at. I know you guys must be looking at it. I know there's a lot of groups looking at it, but just flagging if you're on the call and you're not aware of it. It's one that you might want to look at if you're thinking about AI. Thank you so much, Vanessa, Alex, and all of our wonderful speakers today. Thank you, everyone. It was lovely to see you all. We'll see you all next month. If you've got speaker suggestions, hit us up. We won't promise to follow them, but we'll definitely follow up with them. And we'll see you here next month. Bye, everyone.